Welcome back to a new data science project. In this data science project, we are going to be predicting the exam scores of the students with using the features we have. We are going to do data analysis, we are going to do feature engineering, we will train machine learning models, and we are going to create a Streamlit web app for deploying our model. It's going to be a hands-on coding tutorial, and I'm going to be adding the datasets link in the description of this video. You can see the machine learning app that we are going to be creating at the end of this video from the screen right now. Let's start coding. I'm in the Kaggle page of the dataset that we are going to be using for this project, and our dataset name is Student Habits versus Academic Performance. And it says great for regression, classification, exploratory data analysis, visualization, and even machine learning practice on the description. And I'm going to leave this link in the description of this video. You can just follow this link. After signing in, you are going to be able to download this dataset from the button in here. You can use this download button for downloading the CSV file. And let's take a quick look at its data page on the Kaggle, and then we are going to analyze it more on our code editor. So we are going to have a CSV file like this, and in here we have 16 columns. Like, let me check them. We have IDs, age, we have categoric features, floats, integers, and let me see the target. Exam score is going to be our target. We are going to try to predict that with the features that we are going to select from here. So after downloading the dataset, you can directly add it in your project directory. Then you are going to be able to follow the codes in this tutorial by yourself. So I'm going to leave this dataset link in the description again, and I'm going to be recording back in my code editor right now. I'm going to be using VS Code as a code editor, but you can use any code editor that you want. And firstly, we are going to do data analysis. So let's create a Jupyter notebook. Like, we can like to say notebook.rpmb, and here is my data file that I downloaded from the page that I show you. Now what I'm going to do is, firstly, I'm going to select my kernel, and I'm going to create a code cell, and at the first place we can import pandas. After that, actually, let's import as PD. Then I'm going to say pandas read CSV, and I'm going to take the name from here, like copy the name, and I'm going to save this to something like data frame, and let me make this run, and I will call data frame.head on this. So we are going to see if it's loaded successfully. Okay, we have categoric numeric features again. And in here, let me call data frame.information for seeing the data types. We have 7 objects, 3 integers, and 6 floats. And let me show you the shape. We have 1000 rows with 16 columns. Great. So again, let me call data frame.head. We have student information with their exam scores, and we are going to try to predict this exam score at the end of this tutorial. So in this part, we are going to do exploratory data analysis, and for that, let's make some more imports. I will say import numpy as mp, import matplotlib.pyplot as plt, and import seaborn as sns. Next up, I'm going to set the seaborn's style as white grid, like this. Now let's see the missing values we have. I will say data frame is an A, and it's going to return me cell-wise booleans. If I use sum in here, we are going to see column-wise how much NA values we have. We have 91 NAs in the parental education level, and if we go with sum again, we are going to see the total count on the columns. Right now it's showing column-wise, it's going to show 91. What I'm going to do is, I'm going to say data frame drop NA, and when I make this run, we are going to see that we have a new data frame with NA values dropped. We have 909 rows right now, but if I call data frame and use isNA on that, we are not going to have the modified data frame, because this drop NA method returns a new data frame, but it doesn't directly saves it to the original. So for that, you can both do in place equals to true, which is a method that you can use for setting, or you can just reassign the data frame with this. Let's go with this method. And now when I call this, we are going to see that we don't have any NA values. Great. So let's also check for duplicates. I will say data frame duplicated, and when I make this run, it's going to return row-wise booleans. If I say sum, we are going to get the total count. Okay, great. We don't have any duplicated rows. And one thing I'm going to do in here is I will say import warnings, and warnings, filter warnings, I will say ignore, because I don't want to see any type of future or depreciation warnings from the frameworks that we are going to use. So let's get the summary statistics for numeric columns. For that, we will say data frame describe, and we are going to have this. So the average age in our data set is 20, and with the standard deviation 2, we have the average standard study hours per day is 3.5. We can see the social media hours, Netflix hours, and average exam score is 69 with the standard deviation of 16. Minimum score on the exam score is 18, and the maximum, of course, 100. Okay, great. We can also get the summary for the categorical columns. For that, we will say data frame describe again, but this time we are going to pass include object. So we are going to see that we have category column summaries. In here, we have 3 different values in gender, 2 different values in part-time job, 3 different values in diet quality, and 3 different in parental education, internet quality, and 2 on this side. Also, we can see the top values, like the most appearing part-time job value was no, and it appeared 700 times. And on the diet quality side, we have fair, the most frequent one, with the 396 occurrence. Okay. The most parental education level is high school with 392 frequency. Okay, let's get the value counts for the categorical columns. So for that, we are going to create a list like categorical columns, and it's going to be gender, part-time job, diet quality, and we have parental education level, internet quality, and extra curricular participation. So these are going to be our categorical columns, and also you can get this by calling columns on this, and you are going to get the exact same thing. Both are the options. I just want to show you the both. And in here, what we are going to do is we will say for column in categorical columns, let's say that we want to see value counts column wise. So we will say print value counts for column, and then we are going to say, like, let's say on a new line like this, we are going to say data frame in here, data frame column, and we are going to call value counts. So we are going to have, actually we have a key error. Let me quickly check. It is extracurricular. Okay, so I made a typo in here, and I'm going to make this rerun with this so we don't have an error right now. Let's see the value counts for the categorical ones. Here on the gender, we can see that 400 for the male, 433 female, 36 other. On a part-time job, we have 730 none and 196 yes. Diet quality, we have these values. Parental education level, we have these values. Internet quality, we have these values. And extracurricular participation, we have 620 no with 286 yes. 89, I'm sorry, I missaw it. I saw it like 6. Okay, so next, let's do univariate analysis. And I'm going to create histograms for numeric variables. Rather than categorical ones, we are not going to do anything like a for loop in here. We are directly going to say data frame, histogram, and I'm going to set the bins as 20, and let's set the edge color as black. So now I'm going to say plt title layout, and I will use plt.show. So we are going to have our histograms. In here we can see the distributions, and I'm just going to look for the exam score. We can see a skew in here, but it's like normal distributed if we don't include the hundreds. Okay, we can also create count plots for categorical variables, so we can see this value counts information better and clearer. So we can say for column in categorical columns, we can pass like seaborn count plot. Data is going to be data frame, X is going to be column. Next up, we can give it a title, like let's use a F string with distribution of column. Next, I will say xTix, and I will pass rotation as 45, and I will use plt.show. So we are going to have our count plots ready. Now we can see the information visual on the categorical value counts. Here we can see. Okay, let's create a correlation matrix. So we can use data frame correlation with numeric only true, and we can get a matrix like this. But if we want to visualize that into a heat map, we can use seaborn.heatmap, and then I will say nr is going to be true, and let's use the color map of cool warm, and let's also add a format like to floating. Okay, next up I'm going to say title is going to be correlation matrix, and I will use plt.show after this. And here is our correlation matrix. So I'm just going to look for the values on the exam scores, and here we only have a correlation on the study hours per day, which means that if study hours per day goes up, exam score will go up too. If study hours per day goes down, exam score will go down too. Correlation can take bit values between -1 and 1, and 1 means strong positive relationship, -1 means strong negative relationship. So think it like if you have -1 on any kind of data, and when one goes upside, the other one is going to go downside. So they are going to move oppositely. And the value closer to 0 means there is no significant correlation. Okay, let's do bivariate analysis with target. So I'm going to set numerical features, and I'm going to create scatter plots with them. So we have study hours per day. Actually, let's go with the easy way right now. I will call data frame describe, and we are going to have the numeric column names in here. I will say dot columns, and I'm going to use this list in here. I will use it like this directly, but one thing here, I'm going to remove exam score. It's our target. So we have numeric features. Now I will say for feature in numeric features, seaborn scatter plot, data is going to be data frame, X is going to be feature, Y is going to be exam score. And let's give it a title like feature versus exam score, and I will use plt.show. Here is our scatter plots. So let's take a look at them. So at the study hours per day versus exam score, we can see that if study hours per day goes up, exam score goes up, like we have data points on this side. And also we can see that on others we don't have strong correlations. It seems like attendance percentage is a little bit related with exam score, and on the others with higher mental health ratings we are not having the low exam scores. And okay, we can also go on the categorical features on that. So I will say for column in categorical columns, we are going to use box plots. Data is going to be data frame, X is going to be column, Y is going to be exam score. and we are going to give the title like exam score by column, and let's use xtext rotation 45 and plt.show on that side. Here it is. So we can also see the information on the categorical columns like that. And here we can see that we have similar values on all of them. Like maybe on a diet it differs, like the poor one is a little bit low compared to others. Okay, now we are going to move into feature engineering and creating machine learning models. So let's start with the setup. We are going to say from Scikit-learn model selection, we are going to import train test split with grid search cross-validation. And next we are going to say from Scikit-learn preprocessing, import label encoder. And we are going to say from Scikit-learn.metrics, import mean squared error with r squared score. And from Scikit-learn linear model, let's import our models, linear regression with ridge regression. And from Scikit-learn.ensemble, import random forest regressor. From Scikit-learn.tree, import decision tree regressor. So these are going to be our imports, and we are going to use train test split on splitting our data into training and testing sets, grid search cross-validation on parameter tuning, label encoder for transforming the categorical features into numeric ones, mean squared error and r squared score on model evaluation, linear regression and ridge on the modeling, as well as decision tree and random forest. So firstly, we are going to select the features that we are going to use for our model. And let me call data frame columns with data frame head. So I'm not going to take all of them, of course. I'm just going to select 5 columns to use on the model. And let's say them as features, and it's going to be, of course, we are going to select study hours per day. And let's also select, let me take from here, let's also use attendance percentage. And next I'm going to use mental health rating 2, and I will use sleep hours, from here. And also I want to take part-time job, like this. And let me run that. Okay, we have our features ready. Now we are also going to set the target, exam score, and data frame model is going to be data frame features plus targets. And let's use copy outside. So we are going to have a data frame like this for the modeling. Great. In here we have part-time job. So we need to use encoding technique for turn this into a numeric one. We can't use it like this. So for that we are going to use label encoder, and I will say label encoder. I'm going to initialize it like this, and it's going to be take the no for the 0 and yes for the 1, because alphabetical order works in label encoder and the starting letter N comes before the Y, so no takes the 0 on the encoding part. So we will say label encoder fit transform, we will say data frame model part-time job like this, and we are going to get a series like this with zeros and ones, which 0 means no once again. So we are going to save this as data frame model part-time job. So this is going to be equal to this. And when we call data frame model again, we are going to see that we are going to have part-time job 0 and 1s in here instead of categorical values. Okay, great. Normally scaling can be a good option, but we are going to go with tree-based models So we are not going to do any kind of scaling operation in here. And here what we are going to do is we are going to split the data. So I will say X is going to be data frame model features, and Y is going to be data frame model target, like this. And we are going to use train test split for splitting our data into training and testing sets. And we are going to use training set on the model training, and after that we are going to use testing set for testing our model performance. So we will call train test split from scikit-learn x, y, and we are going to pass the test size of 0.2, which means that 20% of our data is going to be in the testing set and 80% is going to be in the training set. And now I'm going to use two tree-based models, which are decision tree and random forest, and I'm going to do parameter tuning for them. So I will say models, and these are going to be, one is going to be decision tree, and we are going to use that like model and decision tree regressor. Next up, I'm going to say parameters of that is maximum depth. It can take values between, you can extend this list. I'm just going to use these values. I'm going to use minimum sample split 2 and 5, and also let's go with random forest, and I will say random forest, then model random forest regressor. I will say parameters, these are going to be number of estimators. It can take values between 50, 100. You can extend this list again. You can add 200 or 20. Max depth, let's use 5 and 10. Also, we imported linear regression and ridge, but after that I didn't want to use them. But we can also try linear regression. So let's also add that into our model list. For that, I'm going to add that into the first place. I will say linear regression, and it's going to be model is going to be linear regression, and parameters are going to be none, like this. We don't have any parameters on that side. So here we made it run, and now we are going to train our models and evaluate them. So let's create an empty list with the name of best models, like this. And next up, I'm going to say for name and config in models.items, the list that we create, not list, dictionary, I'm sorry, items, we will say print training, and let's pass the name also. Next up, we are going to say grid is going to be grid search cross validation config model, and also config with parameters, and we are going to say cross validation, let's say 5. This means that it's going to split our data into 5 parts, and scoring is going to be negative mean squared error. Next up, we are going to say grid.fit xtrain with ytrain. Now we will say y prediction is going to be grid.predict. So we are going to make predictions with the model we train in here. I will pass xtest, and root mean squared error is going to be numpy square root of the mean squared error ytest with the predictions. So ytest is going to be the true y values, and y predictions are going to be the ones that are predicted by the model trained. Also, we are going to do the same for the r-squared score, y-test, and y predictions. And we are going to append into our list, like in a dictionary format. We will say model will be name, best parameters selected by the grid is going to be grid best parameters, and root mean squared error is going to be root mean squared error. R squared is going to be R squared. So here we are going to train our models and it's completed. So we will say results data frame is going to be pandas data frame best models. So let me show you the best models list right now. Here we have this information, and for a better look we will say results data frame, and let's call the results data frame in here, and let's sort it by root mean squared error. So we are going to have linear regression at the first place, then random forest with the parameters max depth of 5 and number of estimators 50, and decision tree after with the max depth of 5 and minimum sample split of 2. Okay, we have our winner. It's going to be linear regression. Now it's time for exporting this model and creating a Streamlit app for getting predictions from our model. So we can go like, normally we can directly take linear regression and train on the data, but I want to take it programmatically in here. Since we are going to take it programmatically, you can use this with adding other models into this training list, and whatever the model is selected, you can directly take it like this. So we will say import joblib for model exporting, and we are going to take the best row from this results data frame. So best row is going to be results data frame dot sort values. It's going to be by root mean squared error, and we are going to take the ilog 0 like this. So here is the best row, and model linear regression, no parameters, root mean squared error 7.21 and R squared of 0.79. So best model name is going to be, we are going to take from this best row, and we will take the model from here, and we are going to have linear regression in here on the best model name side. So now what we are going to do is we will say best model config is going to be models best model name, and it's going to be empty because we use linear regression like this. And in here what we are going to do is we will say final model, and it's going to be best model config. We will select the model at the first place, and for other models, if you have other models trained, or if you are going to use this codes for other data sets and projects, you are going to say set parameters, and you will pass the best rows best parameters. I'm not going to do that since we have linear regression, but you can use this code for passing the best parameters. So I'm going to save this final model like this, and I'm going to say final model dot fit x and y. So I'm going to retrain the linear regression on the full data, and here we have the model, and let's say that we are going to make this do predictions. We can directly go predict, and for example I'm going to pass x test, and we are going to have our predictions like this. So what we are going to do right now is we are going to export this final model for using it in our Streamlit app. So I will say joblib.dump. I'm going to export this final model, and I'm going to name it like best model.pickle. And now I'm going to have this best model.pickle file in here, and it's ready to get used in my Streamlit app. And on Streamlit what I can do is I can just say joblib.load and best model.pickle. Passing it like this is going to be enough. Then we can use methods like predict on the loaded model we have. So we have our model exported in pickle format in here. Now we are going to create our Streamlit app. So I'm going to create a Python file with the name app.py, and in here we are going to start by import Streamlit as st, import numpy as np, and import joblib for sure for model loading. Now we can save this notebook and close it. Since we exported our model and do our analysis, we started by taking a look at the data and we created visualizations and we do feature engineering and we trained machine learning models. So we are not going to do anything more with this Jupyter notebook. At the first place, let's load our machine learning model. So we will say joblib.load best model.pickle. Let me quickly check the name. Yeah, best model.pickle. Next up, we are going to say streamlit.title. We are going to give a title to our app like student exam score predictor. And next up, we are going to define input fields, like we are going to take study hours, attendance, mental health, sleep hours, and part-time job. So let's go one by one. Firstly, streamlit the slider for the study hours, and on the label side, we are going to say study hours per day, and it can start from 0.0. It's going to be float, so I defined with dots in here. Next, let's set the base value as 2. So the first one is the minimum value, this one is the maximum value, and we are going to set a base value as 2. So for that, for the attendance, we are going to use a slider again, attendance percentage, and it's going to be 0.0, 100.0, and let's set the base as 80. Okay, next up, mental health. So slider again, mental health rating, and it's going to take 1 and 10. It's going to be the range 1, 10, and let's set the default value as 5. Okay, let's go with the sleep hours. Sleep hours, slider again, sleep hours per night, and 0.0, 0.0, and let's set the base like 7. Okay, at the final step, we are going to use part-time job. So I'm going to use a select box in here, and label is going to be part-time job like this, and we are going to say in a list no or yes. Okay, so these are going to be our inputs. We are going to use 4 sliders and 1 select box, and we need to do one thing here. We used in our model part-time job as 1 or 0 with encoded, so we will say part-time job encoded. It's going to be 1 if part-time job is selected as yes, else it's going to be 0. Okay, now we are going to make predictions. So we will say if Streamlit button, we are going to create a button like predict exam score, and if this button is clicked, we are going to say input data is going to be numpy array, 2-dimensional array with study hours, attendance. One thing to mention here, you need to give in the order that you train your model. It's really important. So third one is mental health, fourth one is sleep hours, and we are going to take the encoded version of the part-time job. And we will say prediction is going to be model.predict. We are going to use our model in here, model.predict, and we will say input data. We will pass this 2-dimensional array and take the output value. So we are going to take the exact value of the exam score prediction, and we are going to cap between 0 and 100 because exam score can't be lower than 0 and can't be higher than 100, and prediction is going to be maximum of the 0 with the minimum of the 100 and prediction. So this little algorithm in here is we are going to take the minimum of the 100 or prediction, which means that if we get a minimum value lower value than 100 in the prediction, it's going to be selected, or we are going to select the 100 if it's higher, and in here we are going to limit the output as 100. And at the end, for the final line, we are going to say Streamlit success predicted exam score, and we will pass prediction. Also, let's format it to floating like this. So our app is ready right now. What we are going to do is we will say, actually I also want to import warnings and set warnings.filter warnings ignore, and I'm going to save my file, and from terminal what I'm going to say is I will say Streamlit run app.py. So our app is going to be hosted in this address. You can directly go to this with Control mouse click or Command mouse click, or you can copy this address and paste it in your browser URL for going into this address, and I'm going to be recording on this address on my browser right now. Here our Streamlit app is ready, and we can change its settings by, we can make it wide mode, or we can change the app theme in here, and we can see that we have the student exam score predictor, we have our sliders with the base values we defined with the limits, attendance percentage, mental health rating, sleep hours per night, and part-time job select box. So let's use it. I'm not going to touch on anything, and I will press predict exam score. Here we predict the exam score of 54, and let's test the logic of our app. At the first place, I'm going to increase study hours per day, so we need to get something higher than 54. I'm going to set this to 4 hours a day. Actually, I can't make exact 4, so let's use 430. So now we have the 76. Okay, logic is working nicely in here. Study hours per day, increase the exam score. So attendance percentage, this also needs to increase the exam score. I'm going to increase this one, and here we have a higher one. I'm going to decrease this one, and here we have a lower one. Great. Let's go with the mental rating. I'm just going to increase this, and we have a higher one. Great. Sleep hours per night. Let's say that decreasing this will lead to decreasing the exam score. Great. So our app is working smoothly. Like, we can make predictions from here easily. We can see that the predicted exam score is 72. Okay, great. Now I'm going to go back to the code editor. Here on the Streamlit side, we can close the terminal. We import Streamlit, NumPy, joblib, and warnings. We load our model back using joblib. We give our app a title. Then we get the inputs from the user with 4 sliders and 1 select box. Then we do encoding on the part-time job, and we create a button with the name predict exam score, and we feed the input data, and we pass the model two-dimensional array. We get the prediction and display it in our Streamlit app. That was it for the coding part. Thanks for watching. Let's get to the outro. Thanks for watching this data science project. I have a playlist named Data Science Projects, where I have 40 projects just like this one. You can reach that playlist from the cards of this video or from the links in the description. Also, I'm sharing a new data science video every week on my channel. You can subscribe for more videos like this. Have a great day.